Hello everyone, welcome back to Linear Algebra series. So in this lecture, we will understand about vector and its operation. So far we saw what is vectors, and now let's go more into understanding with an example of what exactly a vector can be in real time and what are the operations that can be performed on it. So before that, let us understand what is exactly scaling. So when we say we are trying to scale something, we basically mean we are multiplying every linear dimension of it by the same factor. For example, we have a square and we are trying to scale it twice. So it basically every dimension of the square will be doubled, and at the end this would change the size but not the shape. Okay. Uh, so yeah, last time we saw what is vector. So in real time, we can consider, for example, in space of all houses, a vector can be something which defines an attribute of an house. For example, 120 square feet, two bedrooms, one bathroom, $150K. So this particular list basically defines a vector in the space of all the houses. Now we can a vector have two different type of operations. One is addition and multiplication by scalar. So when we say addition, so for example, let's say we have this vector r and vector s, and when we try to add this two vector, we basically how addition of vector happens is we need to join the head of one particular vector with the tail of the other. So in this case, if we project the vector s over here such that it basically touches the head of the vector r. So now we can draw a line connecting from tail of r to head of s. So this vector, the newly formed vector, is nothing but the sum of the vector r and s. Okay, so this is how we do addition of vectors. Now let us look into multiplication by scalar. So for example, we have this vector r, and when we say we are going to scale it by 2, or we multiply with a scalar value 2, it becomes 2r. Same way, so it's basically in the same direction, but it is twice the length. Same way, when we multiply by 3, it becomes 3r. If we multiply by 1 by 2, it becomes 1 by 2r. And if we multiply by negative value minus 1, it changes the direction, but the magnitude will be same. Okay. So now let us understand the operation on vector based on one more example. We can define a space with two unit vectors. For example, we have a two-dimensional space which is defined based on two unit vectors I and j, and over here we have two different vectors, vector r and vector s. Vector r is 3 comma 2 coordinates, and basically if we express this in terms of unit vectors, 3i plus 2j is the coordinate for it. So now when we want to perform addition on that, we already know we will create a projection over here, and such that the head of the vector r touches the tail of the vector s. Now we will, when we perform addition on the vector r and vector s, we basically try to add the uh, constant value of the same units vector. So for example, 3 and 2, 3 and minus 1, we add it, we get 2, and 2 plus 2, 4. So this forms a new vector, which is nothing but the resultant of vector r plus vector s. Okay. Now vector addition basically follows the associative principle. So the LHS and RHS over will be same. Okay. Next, let us understand again more about the vector multiplication by scalar. So if we have a vector r, which is 3, 2 over here, and if we multiply by 2, so we are going to multiply each of the component element of the vector by 2. So 3 into 2, 6, 2 into 2, 4. So this is the new vector. So we can see now this vector is in the same direction, but it is twice the length. Okay. Now again, if we want to find minus r, so what exactly we are going to do? Again, we are going to perform scalar multiplication on this vector by minus 1. If we perform, we see minus 3 and it becomes minus 2. Okay, so if we see, the minus 3 and minus 2 will lie over here. So in this case, the magnitude is again same, but the direction has changed. Now, we saw about vector addition and vector multiplication by scalar. Now, let us look into how exactly will vector subtraction take place. Okay, vector subtraction can be converted, for example, r minus s. This can be written as r plus minus 1 into s. So, first we are performing scalar multiplication on s, and then we'll perform vector addition. Okay, so this is how vector addition, subtraction, and multiplication by scalar takes place. Now, coming back to our old example of spaces of all houses, we had a coordinate attributes of houses square, what is the square feet, beds, baths, cost, and we defined a particular house in the space. Now, if we have two such houses, what are the attributes? So basically, we multiply 2 with the vector, and in this case, we will multiply. So how we will do a scalar multiplication? This 2 will be multiplied by each of the elements over here. Okay. So this 120 will become 240, 4, 2, and 300 K dollars. Okay. So this is how operation on vector takes place.